And our final section of Chapter 24, 24.3, Tides. We have two objectives. The first is explain how the moon and the sun affect tides. The second is compare and contrast tidal ranges of different bodies of water. We have three vocabulary terms: tides, perigee, and apogee. We'll talk about those. Make sure you have those definitions in your notes before we begin this section. Key idea: tides, the periodic rise and fall of ocean waters, are affected by the moon, the sun, and the shape of the shoreline. The twice daily rise and fall of Earth's oceans is known as tides, is a result of gravitational pulls from the moon and the sun. So here's a diagram, and we're going to illustrate the different types of tides. So we have the moon's orbit, uniform water level is in that dotted line. On the wherever the moon is, it pulls what's called a direct high tide, and on the opposite sides, it's an indirect high tide. Perpendicular to this is the low tide. Now, tides reach different levels depending on Earth's location in relation to the moon and the sun. High tides are higher and low tides are lower when the moon, sun, and Earth are aligned. Now, high tides are not as high and low tides are not as low as usual when the moon and sun are not in line with the Earth. The sun's tide-making effect is only about half of that on the moon's. Now, the alignment of the moon, the sun, and the Earth occurs at times of new and full moons. The high tides are very high and the low tides are very low. These occur twice a month and are called spring tides. So the position of the moon and the sun are in line. They are both on the same side on a new moon phase, and this is during a spring tide when the highest of high tides occur and the lowest of low tides. Now, a quarter moon phase is when the sun's effect is subtracted from the moon's. The high tides are not very high and the low tides are not very low. These occur twice a month and are called neap tides. So now the sun is on one side of the Earth and the moon is on the other, so they're perpendicular to one another. Now explain what happens to the tides when the sun, the moon, and the Earth are aligned. Now, the high tide is especially high and low tide is especially low because the sun's gravitational pull adds to the moon's gravitational pull. Now, why do spring tides occur twice a month? Because the sun, moon, and Earth are aligned when the moon is full and when it is new, each of which occurs once a month. So spring tides happen during a full moon phase and a new moon phase. Now, during neap tide, what effect does the sun have on tides? Now, the gravitational pull of the sun causes high tide to be less high and low tide to be less low. Now, two terms that you might not be familiar with are apogee and perigee. Now, perigee is when the moon is closest to Earth, and apogee is when the moon is farthest from Earth. So when the moon is at perigee, the closest point to Earth in its orbit, the tidal effect is greater, especially if the perigee occurs during the new or full moon phase. Now, if the moon is at apogee, its farthest point from the Earth, the tidal effect is less, especially much more less if it happens during the quarter moons. Now, another factor that adds to the tidal effect is how close to the moon is the Earth. When the moon is closest to the Earth in its orbit, it is called perigee, and the tidal effect is greater, especially during a new and full moon phase. The tidal effect is less when the moon is at apogee, or farthest from the Earth. Now, the shapes of individual shorelines influence the tidal range. Tidal range is the difference in which water level between high tide and low tide. A narrow bay has a greater tidal range than a wide coastal area. Here's an example of a picture of the Bay of Fundy. This is high tide. The Bay of Fundy is on the coast of Nova Scotia in Canada. And then here's a picture of low tide. This is a very narrow bay. Now, tidal ranges on ocean shores are most noticeable, but they also vary greatly. For example, in the Gulf of Mexico, the tidal range may only be a half a meter. But like in the Bay of Fundy, the range may be as great as 20 meters. What's the difference? It's all about the shape of the shoreline. The Bay of Fundy is a long V-shaped bay, and water from the ocean tide is funneled into that wide end of the V. When the water reaches the narrow end of the V, it pulls it up high, whereas in the Gulf of Mexico, it's reversed. So that V is reversed, and the Gulf has a shoreline much broader than its mouth, and as the ocean tide enters the Gulf, the water spreads out over the long shoreline. I definitely recommend attempting 1 through 6 of the section review to help understand these concepts a little bit better. But before we do that, here's one more critical thinking question. When the moon and sun are right angles relative to the Earth, why don't the tide-making effects cancel each other out? The tide-making effect of the sun is less than that of the moon, so it's not balanced. The moon has about twice as much of an effect on the tides than the sun does. What would be necessary for them to cancel out? Well, the sun would have to be larger or closer to the Earth, or the moon would have to be smaller or farther away. Now, overviewing chapter 24, the first section we did surface currents, currents and winds, warm currents, cold currents, Gulf Stream rings, and countercurrents. Then we went into currents under the surface, density currents from polar water, and density currents caused by evaporation. We also talked about upwelling. And then tides, the moon and tides, the sun's effect on tides and tidal range. That's it for chapter 24.